So students, here is our next experiment for process control 2, which is designing a cascade control system with PID controller. So in this topic we have to just see how to design or model a cascade control system in Simulink using the Simulink library tools, and after that we will design a cascade controller control system using the PID controller. That means we have to tune the controller and we have to achieve the desired output so that it can achieve the desired output, right? So in this part we will see introduction to cascade control system and how to design a Simulink model for cascade control system, and then we will analyze the response. So next, that means our aim of this experiment is nothing but this. If you have any doubt regarding this, you can ask anytime, right? So here, what is cascade control? That means cascade, by the phrase or by the word you can understand, cascade means two or more loops are there or two or more things are there which are combining, right? Combinedly we are trying to achieve a single output, correct? So cascade means here you can see two loops are there, inner loop and outer loop, right? So why we use the cascade system? Mainly the cascade control is mainly used to achieve the fast rejection, as I have written here, fast rejection of disturbance. So means in your plant or in your system, if any disturbances occurs at any point, so that it can minimize before it propagates to another loop or the whole output. This is the inner loop. In this inner loop, maybe there any disturbance arises. So before it propagates to the outer loop or to the plant P1, it minimizes the disturbance using this inner control system, inner loop. So this is how we and this is why we use the cascade system, right? So here controller C1 in the outer loop, this is the C1. So it regulates the primary control variable Y1. That means the output Y1 it is regulated by this controller, right? And the control variable is Y1. This is the set point for C1, right? This is the set point for C1. And controller C2, it is the controller which controls the inner loop, right? Secondary controller, inner loop. And it rejects the disturbance D2. That means D2 is suppose occurring in this point, right, at the output of P2. It propagates or it is propagated by C2 and minimize the disturbance, and so that it goes on further to P1, right? So here inner loop, in this such case of cascade system, inner loop must respond faster than the outer loop, because the effect of output of P1, it is P1 is directly connected to this, na? So if it is if it responds faster and if it minimizes the disturbance faster, so that it cannot be propagated to P1, so that the whole system will be safe, or we will get the desired output as much as possible, correct? So this is how cascade control works. So in this we will see the whole cascade system. P1 and P2, two separate plants are there, and C1 and C2 separate controllers are there. So here first of all we will see how a controller controls the cascade system total inner and outer loop, and further on the next next experiment, we will see the difference between single loop and cascade loop. That means both the control system for inner and outer loop, both will have a output. So difference between the two outputs, if we use two separate controller for the two loops, how it gives the output, there must be a difference. Both the output will not be same. So we'll analyze the difference between two outputs. So first of all, we'll see how cascade control system works, right? So here we'll design a cascade control for a simple plant. Here we have taken an example. So in this example, for P2, that means for inner part, the transfer function is suppose we have taken 3 upon s plus 2, right? It's a first order system. And for the outer loop, plant P1 is 10 upon s plus 1 whole cube. That means it's a third order system, right? So these two are cascaded. So now we have to check, and first of all we have to prepare the Simulink model for this system in MATLAB. So we'll go to MATLAB. So students, here is our MATLAB Simulink file for cascade system. So first of all, you have to open MATLAB, and after that open that Simulink browser, and in that Simulink browser there is Simulink library also. So it will be a blank Simulink model, blank model will be there. So you have to prepare the system by using the tools. Suppose library tools are there, Simulink library tools, as I have shown for the previous experiments also, and you have also done the same thing on process control 1 also. You have operated this Simulink tools. This is the library browser. So in that browser, commonly used blocks and all are there. So just using these blocks, you have to prepare the model. So here it is a cascade. So this is nothing but P2, our plant 2, and this is nothing but our plant 1, right? 10 upon s plus 3 whole cube. We have to just solve and take the transfer function like this. So this is our controller 1, PID controller is there basically. So here the step response or the step signal means for this outer block, whatever set point we have to give, or we are giving, whatever set point we are giving to the PID controller for overall, this is nothing but our step signal, how much desired output you have to achieve. So this is depending upon this inner part also, because the output of this PID is nothing but the set point for this controller, right? So this set point this controller have to maintain for this plant P2, because if any disturbance occurs due to this plant, it will affect this one also. So before affecting this one, we have to control this part, right? So now this is the controller. This controller's input or set point will be nothing but its output, PID is output. So according to this controller's output, this will be regulate, this controller will regulate our inner plant, correct? And after minimizing the disturbance or error, it will go on and pass to P1, and P1 will give the output. This is the feedback for outer control loop, correct? So likewise you have to design. This is the whole cascade system. So first of all, the step we have given like 1. Suppose 1 I have to maintain. You can give 5%, 10%, 20%, depending upon your desired output. I have given suppose 1 for giving you example. And this is the third order system. I have taken third order transfer function. You can take any second order also, and we can easily tune using Zn method also. You can also try the Zn method further I'll say, but here this is the control scheme or control strategy. So Zn can also be applied, but for higher order, if you go for third order, fourth order, it will be very difficult to tune using the Zn method. After finding the sustained oscillation, you have to find out Ku likewise, so Ku, Tu and tuning parameters. So here we'll tune manually. Manually means it will give the output, desired output, as we will tune the controller as per our requirement. So this is the controller PID mode. So first of all I have to tune this one. So I have taken PI. Suppose there are various combinations. This is PI. You can take P and I combination. You can take P and D combination. You can take P and P only P. You can take PID also. So all the combinations you have to apply. I am just showing you here PI only. PI for inner and outer. There is PID already. PI for inner to just minimize the offset or disturbance. Right. So here is a tune. Just you have to select from this list. For P, PI, PD, PID, you have to analyze all the four things, right? And take the output and complete the task as per the direction. But I am showing you only PI here, right? So here is a tune button. Just click on that. So after clicking the tune option, a window will show you like this. This is PID controller tuner. So here you can see slower, faster. One tuning scale is there. Accordingly, you can make the system slower or faster, whatever the desiredness you want. Just see that transient behavior. For transient behavior, another scale is there, aggressive or robust. For robustness, what is robustness? You already know, you have already studied on the theory, and you can go through that also again. If you have any doubt, you can read that. So robustness and aggressive, this is another tuning scale. So depending upon these two scales, you can just tune the controller, right? That means transient behavior should be in normal range, so that we can get the desired output also, and overshoot vagere, whatever the transient behavior is showing, it should not exceed that much value. So accordingly you can tune the controller from here. After that, after tuning, just update the block. Update block. The block will be updated. Okay. So now you can see for here I'll show you another thing. Show parameters. All the things, performance and robustness, you can get from here, right? These are nothing but controller parameters, right? This output is nothing but controller output. That means this type of output we want. This is not ideal. Just I have shown you just how to tune, and whatever desired output we have to achieve, that should be decided by you. How much output I want, how much output I don't want, how much overshoot should be in normal range. I can consider it it is tolerable. So that is analysis is your tasks, right? I am showing you the procedure. So these all the things are, these parameters are nothing but controller output parameter, correct? Not plant. So according to this output, the controller will act. So update block I have done already. So now here you can see P and I have just selected PI mode, so that P and I is there only. So P and I, the value of KP and KI, it is showing here, correct? Just apply and see the output. This is also another PID controller for the outer loop. You can also tune. Accordingly you can also tune the previous controller likewise so that you can get the desired output PID values. Just click here. This output is nothing but the output of inner plant, and this is nothing but output of outer plant. So I have to just update block, correct. Now just run it and see the output. This is nothing but the output, correct. This is settling on 1 because this is the main actual output of the whole overall plant. So from here you can just now calculate the transient and steady state behavior, and this is nothing but the output for outer inner plant. This is the outer plant, outer Y1 you can say, and this is Y2. So for Y2 output, what will be the output? This is nothing but the set point, as accordingly how much disturbance is occurring, accordingly it is minimizing and settling down. So according to this output the plant will behave, and this is propagated onto P1, and accordingly controller 1 will settle down it to 1, as we have given the set point of overall plant output as 1. We have to maintain 1. So from this you can determine the responses, transient and steady state responses, correct. So this is the whole procedure. You have to just do the same task and prepare the experiment manual or journal by your own. And one more thing, just include some theories. I have seen in the previous experiment also, lots of students you have done like minimum theory or whatever. I am just explaining and showing 4 or 5 lines. You are writing only this much. This is just what to write, how to perform experiment, how to go accordingly. I am just showing you. You have to just study and include some theories regarding this. Don't just copy how much only I am giving. Don't just copy and paste like that. Do some work by your own, right? And determine all the things for P, PI, PD and PID, all the 4 modes, correct. I have shown you only this. Here is PID controller, here is also PID controller, but I am using just PI to show you. Just use all the modes, correct, and do the task and complete it. This is your today's task. Okay.